Hi friends, welcome to a co-engineer YouTube channel. Today we discuss about electric field intensity. Here electric field intensity is nothing but E is equal to F by Q. Here F is a force, Coulomb's charge, and it is charge Q. Here F is equal to Q1 Q2 by 4 pi epsilon naught into R square. Here to find out in Coulomb's law Q into Q1 Q2. Here Q2 is nothing but the charge, differential charge Q, 4 pi epsilon naught into R square. In this Q is represented like this Q and Q cancel. E is equal to Q by 4 pi epsilon naught into R square. This can be denoted as in the mathematically they have to be measured in Newton by coulombs or volume by meters. N by C means Newton by coulombs or volume by meters. Here electric field due to a point charge is if the source if a point charge Q, we call all the location of the charge as a source point, and we will the point P which determine the electric field as a field point, which means if the source is a point charge Q. When the source is a point charge Q, we call the location of the charge as a source point. The charge is a source point, we call the point P which determine the electric field as point E is equal to 1 by 4 pi epsilon naught into Q by R square A cap of R. It can be measured by V by M. This is called electric field due to a point charge. This is called electric field due to a point charge is equal to E is equal to 1 by 4 pi epsilon naught Q by R square A R bar. Okay, this is electric field due to a point charge. Now we studied about electric field intensity and electric field due to a point charge. Now we study about electric field due to a line charge. Here this is one of the line coaxial. This is one of the line. In this differential length is there. This is an perpendicular to the x-axis. X-axis k perpendicular to the line is perpendicular to the x-axis. Now we have to discuss the points. Electric field due to a line charge density. This is a diagram for electric field due to a line charge. This is dEx, the x direction. This is a dEy direction. In this y direction, the line charge is this distributed in the y direction. You have to replace the line charge in y direction, which is perpendicular to the x direction. Now this is a displace of the length. It makes angle theta with the angle with we have to make angle is this point and this point any point you have to make this angle with the differential length can make angle with x-axis at any point on this line charge. Now we discuss here points. If a positive electric charge Q is distributed uniformly, whenever the positive unit charge is distributed uniformly along a line, along this line with length 2a, this is a and this is a, the length is 2a, lying along the y-axis between minus a and plus a, which is lying along the y-axis minus a to plus a. This is called as line charge. Now the electric field at point P on the x-axis at a distance x. Now electric field at point P, electric field at a point P on the x-axis, at a distance x. The distance is x from the origin. From the origin, distance is x. Now where the x-axis is perpendicular to the bisector of the charge line. When the x-axis is perpendicular bisector of the line charge, let the length of a typical segment typical segment at a height L be the dl. Here this is typical segment dl, charge of differential length, not charge, differential length and differential charge. If the charge is distributed uniformly, the line charge density rho L at any point on the line. When the charge is distributed uniformly along the line, charge density rho L at any point on the line. This is a line charge. That's why rho L at any point on the line can be formed. Here the line charge is formed is equal to the q by 2a charge by the length of the line. Here rho L is equal to charge by length of the line 2a. Here hence the charge dq in a segment of length dl is q is equal to rho L 2a. This rho L is equal to q by 2a can be transformed to q is equal to charge is equal to length into rho L. Here denoted as line charge. Here differentiate this q dq is equal to dl rho L 2a nothing but dl differential length. Here dq is equal to rho L means q by 2a dl. The distance r from the segment p is root over x square plus y square. So the magnitude of electric field dE at point P due to this segment is E is equal to q by 4 pi epsilon naught into r square is electric field due to a line charge. Due to a point charge, we convert it into line charge. Differentiate this electric field dE is equal to dq by 4 pi epsilon naught into r square. dE is equal to 1 by 4 pi epsilon naught into dq is nothing but rho L dl. Rho L dl by r square dE is equal to 1 by 4 pi epsilon naught. Here rho L is nothing but q by 2a. Rho L is equal to q by 2a. Now substituting this value rho L plus q by 2a dl by r square. dE is equal to 1 by 4 pi epsilon naught q by 2a. R square is nothing but here radius of the distance from segment is root of x square plus y square. R is equal to root of x square plus y square when r square is equal to x square plus y square into dl. Now, this electric field in terms of x and y components, dEx is equal to dE cos alpha, dEy is equal to dE sin alpha. How it can form dEx when the x-axis, when this is a diagram, we have to find out these values. Dx is equal to dE cos alpha, dy is equal to dE sin alpha. The electric field in terms of x and y components, dEx in the x component dE cos alpha, in the y component dEy is equal to dE sin alpha. Here cos alpha is equal to x by here cos alpha in trigonometrically you have to say cos alpha is equal to adjacent side by hypotenuse కాబట్టి now I have to see in this diagram this is an alpha angle, this is a hypothesis, this is an opposite side, this is an adjacent side by hypothesis x by root of x square plus l square. Sin alpha is nothing but opposite side by hypothesis. Here this is an angle, this is an opposite side, this is adjacent side, this is an hypothesis. Opposite side by hypothesis means l by root of x square plus l square. Combining these two equations expressions for dE. Here dEx is equal to dE cos alpha is nothing but x by root of x square plus l square. dEy is equal to dE sin alpha in the y component y direction. Sin alpha is nothing but l by root of x square plus l square. dEx is equal to q by 4 pi epsilon naught into dEx. dE value is q by 4 pi epsilon naught. Here cos alpha is nothing but x dl x 2a into root of x square plus whole square. Here 2a is about the value which is about r square. Here cos alpha is nothing but x by 2a x square plus l square whole power 3 by 2 is nothing but in this r value can multiplying this value. Here dEy is equal to q by 4 by epsilon naught into r square value. This one r square means x square plus l square. L dl by 2a into x square plus l square whole power 3 by 2. To find the total electric field components Ex and Ey, here dEx is equal to q by 4 pi epsilon naught into x dl by 2a into x square plus l square whole power 3 by 2. In the in the y component, dEy is equal to q by 4 pi epsilon naught into L dl by 2a x square plus l square whole power 3 by 2. To find the total electric field components Ex and Ey, integrate these expressions from L is equal to minus a to a. dEx is equal to q by 4 pi epsilon naught into x dl by 2a into x square plus whole square whole power 3. In the direction of x of direction, q by 4 pi epsilon naught into x dl by 2a into x square plus l square whole power 3 by 2. Ex is equal to integral of q by 4 pi epsilon naught into x dl by 2a into x square plus l square whole power 3 by 2. Now integrating this value, now Ex is equal to q by 4 pi epsilon naught, integrating this value from minus a to a x dl by x square plus l square whole power 3 by 2. Now Ex is equal to q by 4 pi epsilon naught into 2a, my integral minus infinity to minus a to a x by x square plus l square whole power 3 by 2 is nothing but into dl. Here this is here this is an even function. Here seen there q by 4 pi epsilon naught into 2a into x, integral minus a to a 1 by x square plus l square whole power 3 by 2 into dl. This is an even function. We have now this is a formula integral minus a to a is an even function. That's why q ex is equal to q by 4 epsilon naught x by 2a. Here even function, that's why integral 0 to a 2 is multiplicable, 2 is multiplicable, and 0 to a, integral 0 to a 1 by x square plus l square whole power 3 by 2, 1 by integral 0 to a 1 by x square plus l square whole power 3 by 2. The formula is nothing but 1 by a square integral 0 to a 1 by x square plus a square is equal to whole power 3 by 2 integral 0 to a 1 by x square plus a square whole power 3 by 2 is equal to 1 by, here the value equation value is 1 by x square into a by root of x square plus a square. This is the formula of 1 by integral 0 to a 1 by x square plus l square whole power 3 by 2 is nothing but have to write this a formation into in formal form q by 4 pi epsilon naught x by 2a 2 into 1 by x square into l by root of x square plus l square. The limits from 0 to a q by 4 pi epsilon naught x by 2a 2 by x square. Here a substituting l, a substituting a by root of l x square plus a square. Now cancel off 2a and 2a, x and x square, the remaining x, q by 4 pi epsilon naught 1 by x into root of x square plus a square. This is electric field intensity due to a line charge in x direction. In the x direction, electric field due to a line charge. Q by 4 pi epsilon naught into 1 by x into root of x square plus a square. Electric field due to a line charge in x direction. In the y direction, Ey is equal to q by 4 pi epsilon naught into 2a integral minus a to a l dl by root x square plus l square whole power 3 by 2. Here Ey value is 0 because y its value is 0. I have to write this points to have to y value is 0, y component will be 0 because of the resultant that ey is 0, because we can also be deduced from symmetry argument if we use a positive test charge at point p. If we use a positive test charge from the point p in the component of x direction, the upper half of the line of charge pushes downwards. ఎప్పుడైతే upper half of the line charge is pushed downward on it, the lower half push up equal to magnitude. When the upward of plus a is going downwards 0, and downward lower half is pushes up with equal magnitude. That's why the value becomes 0 when y component becomes 0. That's why ey value is 0. Now, in vector form, E is equal to q by 4 pi epsilon naught into x into root of x square plus a square a bar x a bar x a x bar a x bar. E is equal to rho l, q is equal to rho l 2a 4 pi epsilon naught x into root of x square plus a square a bar x. E is equal to rho l by 2 pi epsilon naught x into root of x square plus a square a x bar. It can be represented in the values V by M, volume by meter, or Newton by coulombs. This is electric field due to a line charge. Okay, thank you friends, thank you very much.